So we're given an m by n 2D binary grid, which represents a map of ones and zeros. So the ones are land, the zeros are water. They want us to return the number of islands. So what do they mean by island? The definition is an island is surrounded by water and it's formed by connecting adjacent lands horizontally or vertically. So they're looking for vertical adjacency on the ones in the grid or matrix here. So if just looking at this first example, right, we see all of these ones are all horizontally and vertically adjacent, right? So this is just like one island. For the second example, we have some diagonal adjacency, right? So they want to show this top four ones. This is one island. This is another island, a second island here, not connected, right? It's not part of the same island because this is diagonal adjacency. And then same for this other island down here. See, these are connected because they're horizontally adjacent, but it's not connected to this one. So it's three islands. So nothing weird either for the constraints that are going to, alter our solution. But basically, my favorite way, I think the most intuitive way to solve this problem is with flood fill. So we have to look at every cell at least once, right? And then when we're at a cell, well, let me explain just like all together how flood fill works and how this is going to solve the problem for us, right? So like it's really easy to go through and count how many ones there are. It's really easy to go through and count how many zeros there are. But if they want us to like kind of group all the ones together, it's like, how do we do that? Well, flood fill allows us to solve this like pretty intuitively. So let me just actually cut to the chase here. Let me got to add a couple islands to this grid so we've got something to work with. Okay, so just up front, we are looking for the answer is going to be, let's see, this is one or not one island, no diagonal adjacency, right? So this is one island, two islands, three islands. There's going to be four islands here, right? But we're going to start at zero. We're going to use another grid in memory. I'll just cross it out here to show what we've already seen. But in memory, we're going to have a grid, which is the same size as the input grid, but it's going to be Booleans. We're going to flip the Boolean to true if we've already seen that cell. And this is the hack that's basically going to keep us from checking cells more than once when we don't really need to. So, and then when we say flood fill, so let's start looping through all of the cells in this grid. That's what we're going to have to do on the outside, right? So we check this one. Okay, it's just water, so we don't care. But we're going to do something special when we see an island. We're going to recursively depth for search for all the land we can find and then mark it as visited. Once we've done that, then we're going to increment our number of islands, right? And then we will never consider those ones from this island as part of another island, right? So we're at this one. We're going to do a depth for search on all of the horizontally, vertically adjacent pieces of land. Okay. Once we've done that, we mark it, we increment our number of islands here, right? So this is going to go up to 1. And now we've seen it. So we go to this one. And we're only going to be marking our land as seen, now that I think about it. So let me just clean this up really quick. So we're actually just going to mark this one as seen, and then that'll go up to 1. So this is our number of islands. Okay, so then we're at this one. We don't do anything. This one, okay, depth for search, right? We're going to increment our total counter for the number of islands. So that'll go up to 2. This one, nothing. This one, okay, this is more interesting. So we're going to depth for search, go down as far as we can. Okay, go left as far as we can. Okay, go left. Okay, we'll go back up. Back up the recursive call stack, right? Back up here. We try to go right. Okay. Go right again after we would, I don't know, go down first or something, but it's going to be a, depth for search, right? So But I'm not going to illustrate depth first search here. There's probably other videos on that. So we keep going through, right? We're not going to consider, we're here, right? So we go through this level. And then once we get to this level, we're not even going to look at these, right? Because we already marked them as visited. So we're not even going to look at those, right? And then we're going to get to this. We see another one. We'll do our depth first search here. We'll ultimately cross all these out and then increment our island counter. I think I missed incrementing this to 3, but at this point it's going to be 4, right? And that's the answer. So in a nutshell, that's kind of how flood fill works. I know that's pretty rough explanation, but let's code that. So, and then hopefully it makes more sense by the time you've seen all the code, right? So yeah, we want to have a vector of vectors, right? So another 2D grid, another 2D array, this time of Booleans. And the initialization's a little weird here. We'll call it visited. So the first parameter is going to be the number of elements, right? So right now we're setting the type for this guy, right? Like the outer array. So it's first going to be the number of elements to initialize that with, which will be grid dot size. So just the number of rows, right? And then the next element is going to be the type, the value we want to initialize, not the type, but the value we want to initialize for this type, right? And what value do we have for a vector of Booleans? Well, we have a nested, we actually have to specify that we have a vector here, right? So we have a vector of Booleans, and that one is going to be, how big is that one going to be? So this one is going to be the number of columns, right? So columns, grid 0.size, and then all of those values will be false, right? So this is like a value. It's interesting. It's like nested here, right? So we have the number of them, and then what the value is. We have the number of them, what the value is. So that's our visited thing. We're just making that whole grid in all to be false at first, at the identical sizes grid, just all in one line. That's how you do that. And then we also want a tracker. We got a counter, right? We got to count the number of islands. So that'll just be 0 to begin with. And then we just want to loop over that input grid. So we'll say I equals 0, I is less than grid.size. So we're looping over the rows. Then we want to loop over the columns. So we'll use J. This is just the convention, right? I and J for these like C style loops. So we'll do J less than the number of columns. So grid, we're just taking the size of the first row, right? That's how you get the number of columns. And we know there will be a first row because of the constraints. They say there's going to be at least one element. So that's why this is always like safe to do with the input they've given us. Right. We would actually have to check, if it's potentially like empty, then this would be dangerous, but we know it's not going to be. So anyways, what we want to do at this point, so we want to check if there is land here, and we want to check if we've, let's see, we want to check if there's land here, right? So we'll say if, if grid I j is equal to 1, right? And we also want to check if we've already visited this cell or not, right? So we know whether to start our flood fill. So let's just do, so if grid ij equals 1 and not visited ij. Okay, so at this point, we're going to make a recursive function called flood fill, which, we haven't done yet. And then after we've marked all of those potentially adjacent ones as visited, we can just increment our number of islands a single time here, and then finally return the total number of islands we've seen at the very end. Okay, so let's code that recursive function, right? So this is going to be a depth first search. Let's just make it a private function member of solution. So we'll say void flood fill. We're going to need a couple of parameters, right? We need the original grid. We're going to want to also pass this visited grid, right? So this one is a Boolean 2D vector of Booleans. And then we also want the coordinates right in our depth first search. So this is like a DFS on the grid in J. Okay, and then the whole point of this is just to mark all the adjacent ones as visited, right? So we don't count them again, like recount them for other islands, or not recount them, but consider them for other islands. And then like doubly count inadvertently. Anyways, yeah, so we're going to check first. Okay, is the cell that we're currently on, land, right? So if grid I j is not equal to land, or what's another condition where we want to return immediately? So if it's not land, and we can actually, it's going to be either land or water. So we'll just say if it's water, or if we visited I and j, then we can just immediately return. We don't want to search anymore. Okay. Otherwise, we at this point can finally mark this cell as being visited, right? So we never, because we're about to do these recursive calls, right? We've got to say visited equals true now before we do the recursive calls. That way we don't, retrace our steps like crazy. So now that that's visited equals true, we're going to try searching in all four directions, right? And then just rinse and repeat, do the same thing, right? So we'll say if I plus 1 is less than, we've got to do this check to make sure we're staying in bounds. We could also do that up here, but I'll just prefer to do that right before we make the recursive call. So we'll say I plus 1 less than grid.size. If that's true, then we can call flood fill, right? That direction. So we'll call flood fill on grid visited I plus 1 and j. Okay, and then we basically have to do that like all four directions, right? So if we want to make sure we don't go out of bounds in the negative direction, so we'll say I greater than or equal to 0, grid.size, and it won't be grid.size, it'll just be I minus 1 greater than or equal to 0, right? And then we'll say I minus 1 here. And then for this one, we'll say j plus 1, and we actually want to do the comparison against the number of columns, right, for j. And then increment j. And then for decrementing j, it'll be a similar thing, right? We just have to make sure j minus 1 is actually in bounds before we make the call. So j minus 1 greater than or equal to 0. Okay, and that should be, this is pretty much it, right? So let me make sure we're code correct here. And then, that is something we have to do. Grid visited I, j. Okay, that should be it. Okay, so this is we solved this with like a recursive depth first search version of like flood fill, right? So the time complexity will be big O of m times n. Space complexity will be big O of m times n as well. So hopefully this helps, and I'll see you guys in the next. Peace.